So today we're in section 5.1, ratios and ratio tables. We're in our books on, and we are going to use our books a little bit today. We're in our books on page 184. Page 184 in your books. Page 184. There's a couple of key concepts here that I want to talk about before we really get too much into or too far into the lesson. It's my understanding that you guys did learn ratios in 6th grade. As far as like, there's 3 ways to write a ratio. You guys remember that? There's 3 ways to write a ratio. Let's take the ratio 3:2. Okay, that's the one that we're kind of doing on the slide. We can write it with a colon, 3:2. We can write it as a fraction, 3/2, or with the word 2, 3:2. In all of these ways, and I know I'm kind of like writing it at the top of the screen, but this is kind of some background knowledge that you need to know in order to understand the lesson today. Basically, what a ratio is, it's a comparison between 2 quantities. Okay, here's what I need you to understand though about ratios, and this might be a little different than what you've or how you've viewed them before. A ratio is actually a division between the first quantity and the second quantity. After all, isn't that what a fraction is? Dividing the top number by the bottom number. Would you agree? Isn't that what a fraction is? 3 divided by 2. So we haven't necessarily viewed it that way in the past. We've always viewed it like 3:2. Or 3/2, but essentially what we're doing in a fraction is we are dividing. So that's what it's showing us here, that you are dividing the first quantity by the second quantity. That's so important when it comes to finding the value of a ratio. And that, guys, is like the core of what we're learning today, finding the value of a ratio and understanding what that means. All right, so go ahead and write this down, and then we'll go over what all of this basically is saying also. All right, so 3:2. All right, when I write it with a colon, that's the same thing as writing it as a fraction. That's what we just talked about. Now, something that we probably have not seen before is a whole number being compared to a fraction. Okay, and you're going to see that through this entire lesson. There is no avoiding the fact that we're going to compare 3 to 1/2. So what does that mean? That means that I can put that into a fraction. The whole number 3 over 1/2. I know that's kind of weird to put a fraction into a fraction, but that's essentially what we're doing. So you need to understand whether it's whole numbers or fractions, I'm dividing the first number by the second number. All right? And I'm going to skip over the table here for just a second and do this example, and then we'll come back to the table. All right. The Flubber chart, you don't have to draw this because it's right there in your textbook on page 184 on the left-hand side. You see it like it's like a ripped piece of paper? You guys see that? Page 184? Okay, so it's right there, so you don't have to write down this chart. Okay. Now, what does it want? It wants the ratio of what? Cold water to glue, okay? So I want you to write this as a fraction, all right? Technically, you could write it any of the 3 ways, but I want you to write it as a fraction. I know it's kind of weird because it's essentially going to be a fraction over a fraction, all right? But what is the amount of cold water? 3/2, okay? So we have 3/2. All right, and what number goes in my denominator?
2.
All right, glue is 2. And because it's all the same unit, I can just say 3/2 over 2. I had to do the slash because I just didn't have enough space, but I'm writing it as a fraction, okay? So that's it, all right? I wrote my ratio. But now in letter B, it wants me to find and interpret the value of that ratio. So here's what I do, and this is how I find all of my values. I divide the first number by the second number. 3/2 divided by 2. This is something that you can do in your calculator. Okay? 3/2 divided by 2. But I am going to show you here. Now you can do it in your calculator. But if I divide by 2, which we know that this is 2 over 1, what is happening when I divide a fraction or a whole number that I have to flip it? So essentially this is 3 over 2 times 2. Okay? All right, so that's what I'm doing to find the value of the ratio. All right, and what did you get if you... I did flip it. Oh, yeah, my bad. All right, 1/2, sorry. Okay, so what do you get when you do 3 over 2 divided by 2 or 3 over 2 times 1/2? Okay, 3/4 is the value, okay? So how do I find the value? I divide the first quantity by the second quantity to get 3/4. Okay, so that's the first answer. That's the value of my ratio. Now it wants us to interpret what this means. Okay, so let's think about that for a second. That the amount of cold water, all right, again, I'm comparing cold water to glue. So the amount of cold water, and I'm going in this order for a reason, it's cold water to glue. Is 3/4 the amount of glue in the recipe. Okay, how do you think this would be beneficial to know that, okay, basically no matter what quantity, let's say I wanted to use and this is going to make it a lot more, but what if I wanted to use 10 cups of glue? Okay, now we're just comparing these two quantities. What if I wanted to use 10 cups of glue? Well, this value is telling me, okay, if I want to use 10 cups of glue, how much water would be proportionate or the same ratio? I would take 3/4 of that amount, and that's how much water it would be. So the value of the ratio shows me how the quantities are connected. All right, so now let's look at how this looks in what we call a ratio table. All right, you with me? Sort of. All right, so in a ratio table, all right, now your book does not give you this middle row, all right, but I feel that this middle row is very important and it makes it much easier for you to understand what we're doing here. So this middle row, I'm going to have you write on all of your homework questions. You say, well, the book didn't have that middle row in the ratio table. I know, but what I want you to do is I want you to write that in when you're copying it out of the book. Does that make sense? Okay, so this whole value of the ratio, what we just did in example 1, we can use that information to create what we call equivalent ratios. Okay, so go ahead and write down this table, fill in the values that I have in there, and then we're going to find the missing values. So what I'm going to do is look at the very first, basically at some point in the ratio table, and it's usually the first column, I have a complete ratio. All right, so what I need you to understand is I can actually pull these values out of the table and write it 18/3. Remember, it's a comparison between two quantities. So 18/3, which would be helpful if I unfroze the screen. All right, I want you to go ahead and pull that out and write it as a ratio. Okay, and remember what we said. How do you find the value of the ratio? You divide the first number by the second number in that order. So what is 18 divided by 3? 6. So I have now found the value of the ratio. And it's going to be the same value across the entire ratio table. It has to be. In order to create equivalent fractions basically with the same value, I must be using the same value. Okay, so it's got to be 6 all the way across. And now I have the information to fill it in. Well, let me ask you this though. If I divide when I'm going top to bottom, what do you think you're going to do if you're going bottom to top? Multiply. You're going to multiply. What is 5 times 6?
30.
30. All right, so fill it in. 30. All right. Now 42 to 6, and go ahead and fill in the last two blocks following the same pattern. Go ahead and fill in the last two blocks. There's no work to show. Okay. What's 42 divided by 6?
7.
7. And what's 4 times 6?
24.
24. Did you guys get those values?
Yes.
Okay, so now what your book is going to ask you, I think on numbers 15 and 16, is to write the equivalent ratios. All right, so what it wants you to do is to understand that what we've done here in this ratio table is we've created several ratios that are equivalent in value. All right, so now let's prove it. All right, go ahead and pull out each one of these ratios. 30 over 5, 42 over 7, and 24 over 4. All right? What happens if you reduce each one of these?
They equal 6.
They all equal 6. They all have the same value. They are all equivalent. Okay, you see that? So it's really cool how we can use the value of the ratio to actually create. Do you guys agree that these are all different fractions, but they all have the same value? All right, and just like that, you're that much smarter. Congratulations. I'm just kidding. All right, so let's do more of this. Okay, we're going to kind of go back a little bit just to one ratio. I want you guys to work together to find and interpret the value of the ratio of baking soda to salt, just like we just did with the flubber. And then we're going to do 2 more ratio tables and 1 more example and we'll be done. Okay, so I know I say we'll be done. We still have a little bit left to go, but go ahead and just work this with the people in your group. Okay, so again, we're comparing the first quantity to the second. So 2/3 divided by 3. Okay, essentially we put it into a fraction. Some of you are writing the division symbol, and that is fine also. Just knowing that you're dividing and you get 2/9. But what does that mean? That means that the amount of baking soda used is 2/9 the amount of salt. All right, so now you can increase the recipe. Has anybody ever doubled a recipe or tripled it if you were making it for like a lot of people? So now you understand the ratio at which you're increasing it. Now, if you're doubling it, you're just multiplying by 2, okay? But what if, it's not quite that or, whatever. This is basically how we find the value of the ratio. All right, so let's do a couple more ratio tables. All right, so the fractions, they're going to be a part of pretty much every lesson that we learn, but that's okay. We understand how to get that missing link or the value of the ratio, and it has to be the same across the entire table. All right, so go ahead and try to find, based on what we've been doing already, try to find what the value of the ratio would be. So again, we find the value by dividing the first quantity by the second. What is 3 divided by 3/4?
4.
It is 4. So 4 is the value of the ratio across the table. 4 is the value. So if I'm going top to bottom, I divide. What is 12 divided by 4? 3. Okay, now, and we're going to keep it a fraction. Please do not write decimals. All right, we're going to write them as fractions. What is 15 divided by 4?
3 and 3/4.
No, write it as an improper fraction. 15 over 4. 15 over 4. Okay? And now, hold on though. Now I don't know the top value. So what would I need to do to find the top value? You just have to leave it a fraction, Kiana. You just can't have it a decimal. All right, so if I need to find the top value, what do I need to do? I need to multiply. What is 5/4 times 4? 5. Okay? Now I have my table filled in, and I need to write all of my equivalent ratios. I would suggest when it's a fraction, you could write it with a colon. That's what they did in the book. Writing it as a colon, or you could write a fraction over a fraction. but I kind of tend to side with the book that it's maybe a little easier to read. All right, so 3 to 3/4, that's my first ratio. And again, the value, comparing the two is 4. 12 to 3. And if I divide all of these quantities, the first quantity divided by the second quantity, I'm going to get 4 every time, so the value is the same. 15 to 15/4. And 5 to 5/4. All of these ratios are equivalent ratios, and their values are all 4. Okay? All right, any questions? We're going to do one more just to kind of bring it home. Okay? All right, one more. It's smaller. It's only 3. Smaller. It's only 3. Okay, remember, two ratios that describe the same relationship are equivalent, so that's what we're doing here. Find the value, fill in the rest, and write the equivalent ratios. All right, so now we're getting a little quicker at solving these. Okay, so the missing link, again, we divide the first value in the ratio by the second value. 5/2 divided by 4 gives me 5/8. It's okay for the missing for the value to be a fraction. That's okay. So that means the value has to be the same all the way across, 5/8. Okay? All right, so on the second one, I'm going from the bottom value to the top value. So what do I need to do? Multiply. And when I multiply, what do I get? 10. All right, now in the third value, I need to divide. And what do I get? 8. So now pull them out. Write your equivalent ratios. All right, 5/2 to 4, 10 to 16, and 5 to 8, ironically. All right. And all of these ratios are equivalent ratios. Why? Because they all have the same value. All right. All right, one problem on your homework tonight that's like this. It's number 20 on your homework, okay? You are going to use a proportion, which is two ratios equal to each other, to solve for the unknown value. All right? Now remember, a ratio is a comparison between two quantities. All right? So how could I write these values in a ratio? How could I write it? And we're going to use a fraction, 14.5/3. 14.5/3. But when I'm setting up a proportion, it is very important. This is like pretty much the only way you can go wrong when you're setting up a proportion. You have to make sure you set up the other side to match the same values. So what I'm saying is 14.5 was miles, right? Or distance. Yes. And 3 was time. So on the other side, it has to be distance over time. Okay? Now, if on the first ratio you had done time over distance, that's fine as long as the other side is time over distance. But it has to be the same quantity on both sides. Okay? Top and bottom. All right, so now, how far does the satellite travel? I don't know how far, so that's going to be my variable. And I'll just use X. I mean, you could use X, you could use D, it doesn't matter. Okay? Now, here's my challenge 2. Of course they do this to us. All right, now don't say it out loud, but this is a different unit. The first ratio was in seconds, but can I figure out, don't say it out loud, can I figure out how many seconds are in 3/4 of a minute?
Yes.
Okay, think about it. All right, so how many seconds are in a whole minute?
60.
60. Okay, so if I were to divide that by 4, that's 15. So 3/4, 15 plus 15 plus 15 is
45.
45. So that's why the 45 goes in the denominator. Okay, does everybody understand where I got 45?
Yes.
So if I had said half, it would have been 30. If I had said 1/4, it would have been 15. What if I had said 1/3?
Oh my god. 26.
20 seconds. Very good. Okay, so we just divide however many seconds are in a minute by, however many we're chopping it up by. Okay? All right, so now that I have my proportion set up, guys, stay with me. We're almost done. I'm going to use a method called cross products. It's a very simple method. Cross products say that I multiply the terms diagonal from each other and I form an equation. What's 3 times x?
3x.
All right, so write 3x. Okay, you're probably going to need your calculators. What is 14.5 times 45? 14.5 times 45. 14.5 times 45.
652.5.
652.5. Correct?
Yes.
Okay. So now, what am I going to do? I know 652 is a little bigger, sorry. All right, what do I do to both sides? What do I do to both sides? It's been a long day.
Divide by 3.
Divide both sides by 3. And x equals 217.5 what? What's my label?
Minutes.
Nope.
Seconds.
Nope.
Miles.
Yes. Okay, remember it's miles over seconds. Okay? So on your homework tonight, when you're setting up your proportion, make sure you're setting up the same quantities on top and the same quantities on the bottom to match them up. Do your cross products and solve. And guys, please get your label right. All right, so this is saying, and I don't know how realistic this is, but literally in 45 seconds, it's saying that this satellite can travel 217 miles.
That's
Okay,
a lot of miles.
which is approximately the distance from here just to the other side of Tallahassee. Okay, in 45 seconds. All right, so I don't know, maybe it does travel that fast. If you understand that, guys, quiet. If you understand that, that's everything you need to know for 5.1.